You'd have to put in a waterbed. You'd have to put in a hot tub. All these things you don't want to do while you're driving your van. But with Asterisk SCF, if you built a vehicle or a communications application, it would actually be a lot more like a train than it would be like a car. It's a bunch of linked components, which means you can modify and add components while the train is moving. You can add more capacity while the system is operating. When you deploy additional components, the rest of the system just sees them and the capacity appears. Now, of course, this is all made possible by something. It's not just magic. And that's because the architecture that we chose is called a distributed application. A distributed application is components that all perform single functions that communicate with each other over some kind of messaging system. In this case, they use a very high performance and multi-platform messaging system, which also happens to be open source. And that allows those components to be located wherever you need to locate them. One computer, multiple computers on a network, computers spread all around the world, virtual computers in the cloud, whatever you need, or some mixture of all of them. It also means that the number of components you deploy is dictated just by your requirements. So if your requirements are you need to handle a great deal of voicemail, well, you'll have more voicemail components than another system might have. And as your needs change, you're only going to have to deploy the components that you need to address those specific areas of functionality. When you deploy those additional components, the system sees the increased capacity appear. Now, we're going to talk a little bit about how that architecture addresses those goals that I talked about. You don't have to understand what's on that slide right now. We're going to break it down in little pieces here in just a second. Next. There we go. All right. So the first goal that I mentioned was performance. Single computer communications applications can actually do quite a lot. People have actually run an incredibly large number of calls through single systems in the last year or two. But they're still limited by the fact that they run on one computer. And that makes them hard to scale, makes them hard to achieve very, very large call volumes. It also means that you can't easily take advantage of cloud computing, scalable computing, whatever term you want to use for how that is done. Well, with the Asterisk SCF architecture, every component can run on a different CPU, different computer, whatever you want, but they all appear to be a cohesive system. That, of course, leads to scalability. How am I going to grow my system? Well, with traditional applications, this can be done. It's clearly not easy. Frequently requires additional applications and coordination amongst all of them to make sure all the features you want work. The architecture that we've decided on for Asterisk SCF allows for capacity to be added to an operating system. So you can see on the screen there, we've just added more capacity, and yet the system still works as a cohesive unit. This is done by following 4 design patterns, as they're called in software development. Discovery, meaning the components don't have to be configured to know where the other components are. They can locate each other on the network when it's required. Managed deployment, allowing you to just put the components you need where you need them. Distributed processing, of course. If you've put those components on multiple machines, you're going to gain the benefit of utilizing those multiple machines. And finally, breaking the application into single function components means if you put a function on a machine, you're not going to waste any resources doing functions that machine doesn't need to do. Now, of course, we had another goal, fault tolerance, which we heard about from Tim. And again, that can be very hard to achieve with traditional communications applications. They're not designed to be able to provide what we want for availability. If something goes wrong in that application, it will usually crash, and then you lose all the calls that were in process at that time. Well, the architecture of Asterisk SCF, again, with every component doing a single task, means it's possible to build replication between individual components, as you can see on the slide there. That means that all the information that one component is managing about a call can be replicated to another copy of that component on a different machine, so that if a failure was to occur, failover can happen with no disruption of service at all. And of course, we had a 4th goal, which was extensibility, which Willie talked about. It's really impossible, and no surprise at all, that when Mark released the first versions of Asterisk, he could not have envisioned what people would be doing with it today. It's impossible for any software developer to do that. So the best we can do is we can build the system so that when you come up with some creative application in the future, the system will be able to accommodate your needs. So with Asterisk SCF, much like with scalability, we have 4 areas that we're focusing on to provide you what you need there. The first are the system's APIs are all well-defined, documented, and they'll be version managed so that if you build an application on top of Asterisk SCF and a new version comes along, things will continue to work the way you expected them to work. And we have a brand new concept called extension points. These are methods that a developer can use to modify the behavior of an Asterisk SCF component without actually having to modify the component at all. Ways to change its behavior at runtime without modifying it. And then finally, based on requests from users, we're going to have broad operating system support. Linux, Microsoft Windows, Solaris, Mac OS X, I'm sure many others. And even more importantly than that, all of these things we're talking about for extensibility are available in a wide variety of programming languages. That's including C++, C#, Java, Python, and a lot of other languages, including languages on mobile platforms. So, those are our goals. We've talked about how Asterisk SCF is different from Asterisk, like comparing a train to a kit car, collection of parts to a kit car, I guess. We've also talked about what our goals are and how we achieved them with the architecture. So our next task here is to teach you about the architecture of Asterisk SCF. So this is what it looks like. For the next hour and a half, we're going to go through each one of these little blocks up there, and you guys are going to understand how Asterisk SCF works. So this afternoon, you can go start writing code and help us out. So first of all, if you brought your graphing calculator or your slide rule, you're going to need to get it out. If you don't have a PhD in theoretical physics, this might be time for you to leave the room. Bazinga. We're not actually going to do that. We're actually going to do something fun, and we'll have that discussion later this afternoon for those of you who are interested. So I mentioned that back in March, we started design and development of this, and of course we have something we want to show you now, otherwise we wouldn't be doing this keynote. We're actually going to be doing a demonstration which involves both Asterisk SCF and Asterisk 1.8. And we're going to demonstrate live call failover between 2 data centers running Asterisk SCF. One of them is going to be in Scranton, which you saw a picture of before. And of course, the other one will be in Huntsville because that's where our office is. We're going to need some helpers for this, though. So any of you who have brought mobile phones with you, and I'm sure that's not very many, who are willing to make a call for about 10 minutes to a U.S. phone number, raise your hand. Stay in your seat and just raise your hand. Wow, almost nobody has mobile phones. What's up with that? David Duffett's going to come around, and he's going to randomly select 10 of you to participate in this demonstration.
These guys are going to need films.
That's right. If you want to get his attention, you probably, get his attention. Do something creative. Sing, dance, whatever you need. So for any of you that he gives a card to, there's going to be a phone number on it. We need you to call into that phone number. You're going to be dumped into an Asterisk Meet Me conference bridge, which you're all familiar with. You're going to be the only people in there for right now, so just hang out. We'll need you in a few minutes. In addition to those volunteers, Danny Wyndham and Mark Spencer are going to help us with this demo as well. So guys, come up here. And they're going to... Uh-oh, they took the lights away. What are you going to do now? So, all right, we all set? Great. Everybody who got those cards, go ahead and call in. So you can see now up on the stage, we have 3 data centers. These data centers are all participating in an Asterisk SCF cluster. Since those components we were talking about don't care where they live, it means you can put them on any computer in any place that you need. So let's go to the next one. So this is the rack that represents the Washington, D.C. data center. Amazingly, we're right here in well, actually, we're not in Washington, D.C., but we're pretty close. In this rack, we've really got 2 servers of importance. The first is the one that's running most of our Asterisk SCF cluster. It has a lot of components on it. But the really important one is, of course, the state replication service, the one that's going to allow us to do live call failover. Now, of course, since Asterisk SCF is really new, it doesn't have conferencing or lots of other things yet. So we also have an Asterisk 1.8 server in here. It's connected to the soundboard in the room. It's connected to the telephone network. And it's connected to the conference bridge that you all just called into. So if you're in that conference bridge, just say hello now so we know you're there.
Hello.
Is it coming out?
Hello? Yeah, hello.
Okay. It's going to be kind of quiet because otherwise we get feedback on cell phones.
Hey, you're breaking up.
All right. So, next slide, please. All right. So now we have this data center right here. This one's a lot more simple. This one's located in Huntsville. Has our wonderful CEO standing next to it. It has 2 servers in it. One of them is, each of them actually, are running the Asterisk SCF SIP session manager. One of them services Danny's phone right there on that table. And the other one is the backup for the one over there, which we're going to talk about right now. This is the Scranton data center. It's just like the one in Huntsville, except it has our CTO standing next to it instead of our CEO standing next to it. 2 servers, one of them running a SIP session manager for Mark's phone, the other one running a SIP session manager as a backup for Danny's phone. Now, they're going to call into the same conference bridge that you guys are in, and they'll be in there in a second. Go ahead.
Hello, Mark. Hey, and I'd like to welcome everybody to AstroCon and thank everybody that's calling in for the first public phone call on Asterisk SCF.
Hey! All right. So now, some of you who've been around data centers may have seen things like this before. Okay, clearly you have. This is a big power switch. So you can probably guess what we're about to do. One of these data centers is going to lose power pretty soon. But we don't know which one. You guys are going to decide for us. So in Huntsville, as it turns out, in spite of the tornadoes they were having yesterday, there is a fleet of backhoes running around the cotton fields. And unfortunately, they're being driven by a union of disgruntled IT workers. Yeah, there you go, right? So it's possible we're going to lose power here. Now, we've also heard that for some reason, there's a school of saltwater sharks in the river outside of Scranton. And of course, the power cables run through the river, so you know how sharks are. So, anyone who thinks that it's going to be the backhoes that are going to cut power to Danny's data center, you should probably applaud now. Whoa! Whoa! Well, you might be safe, Mark. Anybody who thinks it's going to be the sharks that are going to cut power to Mark's data center. Oh! Wow, we're so surprised. We didn't expect that at all. All right, here we go. All right, so this data center just lost power completely.
You good?
They're still on the call. No disruption at all. People on the mobile phones, are you still there? Yay! All right, everybody's still there. So that was obviously a fairly catastrophic server failure. We were thinking about doing worse, but that's good enough. Now that's a fairly decent demo, but now we're really going to show you something incredible. Because the server that was servicing Mark's call, all that state was transferred over here, that means Mark can still control that call. So now he's going to transfer it to me on this phone up here on the stage. Go for it.
All right.
Are we there?
Hello, Kevin.
Look at that.
Woo.
We're there. We transferred the call. All right, so all of you that are burning cell phone minutes can hang up now because the demo's done. So the whole call was still intact. We were able to transfer it after the server that was servicing that call died, gone. Now, some of you are probably pretty adventurous and wondering, hey, can I do this? Sure, you can do this. Of course, since this is an open source project, this is all going to be made available very soon, although we're running a little behind. We'll have a developer release of Asterisk SCF available hopefully later today.